Hello everyone. Thank you guys for joining us. Our today's session is on face painting using TFJS by our speakers Samarth and Praveen. Samarth is a freelancer, interaction designer, UX educator, and Praveen is an independent product consultant and creative coder. Together, they had built a face paint AR filter using TFJS Face Mesh API, which was used to run a social media campaign for the Chandigarh Museum for World Environment Day. In today's session, they will share their experience in exploring technology and building a tool for digital artists to try AR face filters without learning a tool or learning how to code. Welcome, Samarth and Praveen.
Hey Smith. Hey everyone.
Hi.
Okay. So we shall be starting today. Okay. Thank you everyone for
Yes,
coming.
yes.
Okay. Thanks, Smith. Okay. So I hope everyone is doing good during this lockdown period. Since every time we see every city is having a lockdown again in their city, plus there is the weather condition on the northeast. So I hope everybody is doing good. Okay, so today we will be talking about our experience and sharing, like how we work with TensorFlow.js face mesh model to create something about face painting and AR, and finally getting to a campaign we did with a museum. Uh, so Okay, so starting with our introduction, I'll just get to myself. So as Smith also said, but still I'll reintroduce what I generally do. So I'm also a creative coder and designer. So you could see like I work with data visualization, sometimes generative artworks, and recently I have gone into the area of AR filters in Instagram and even without the Instagram, which you guys will be looking at. Plus, some other times I work with some the visual creative tools, something like Touch Designer to create real-time graphics. Uh, then let's get to Samarth. Samarth will take over from now. Samarth, let's just. Just a second, guys. I think Samarth will be joining. Okay.
Yeah. Thanks, Praveen. So as Praveen mentioned, we just did an exploration around TensorFlow.js, and just to introduce myself, I come with a background in UI development. I worked for Adobe for about 2.5 years, and now I'm currently working as an independent consultant. This is one of the projects I shipped at Adobe for Adobe Stock, which allows you to search for images with multiple parameters. On the side, I do a lot of generative art and creative coding. And if you see, there is one for a lot of these optical illusions which I make, and also do a bit of the plotter work where I have like an XY plotter and put these out as generative art pieces. So to get started with the thing, Praveen and I met over at PCD. PCD is Processing Community Day. It's an amazing festival run by a lot of creatives who work in the new media field. And so there was one hosted in Delhi earlier this year where Praveen and I met up, and we always wondered like if we could work with some museum or a gallery to put up our own creative endeavors on their floor. So we came about this opportunity by Science Gallery Bangalore, where they had an open call by the name of Contagion. It had to do something with the current coronavirus situation as well. But we thought of like what can we do to kind of emphasize how things have changed in this new normal. We thought of like a lot of these communications these days are happening over text messages where we are stuck in our homes and are communicating with others without the non-verbal cues that a lot of these face-to-face interactions provide us. So we thought of like how can we teach or like emphasize the importance of these. So we thought of having like an Animoji conversation tool, which would just have you talking to each other through face expressions, but at the same time we wanted to preserve the anonymity. Another downside of using Animoji directly was that it was very platform dependent. So we wanted something which is platform agnostic, and that's where we felt something browser based would really shine here. It was just a coincidence that TensorFlow at that time came up with their face mesh model, which, as you can see in the GIF here provided by the developers, it's very responsive and works directly in the browser without any privacy concerns, as all the computation for this is happening directly on the client side. Another benefit here is that all the data stays on the client side, it doesn't go to a server, so that it also adds an additional layer of benefit for us. Now, it just happened so that I was exploring WebGL at the same time as well. And for that, I started to get to like the weeds of it, how to get started initially without any library whatsoever. So just vanilla JavaScript. And I came across this really helpful website, WebGL Fundamentals, and goes through like step-by-step process of making a WebGL example from like basic triangles to all the way to like a full-fledged game inside the browser. And so we started off like taking the initial demo code provided by TensorFlow Face Mesh and seeing how we can implement it with WebGL. So the WebGL has this really nifty little thing about GL points where it can render dots at a specific location. And that's what basically what TensorFlow Face Mesh provides us. So if you put up a webcam feed into the prediction model, it will give 468 points in response, which then I send it over to WebGL as GL points, as you can see in the primitive type. And then it draws all those points on top of the video canvas. Now that's where like the hype curve comes in. So Gartner has put up this technology hype curve. Like whenever there's a new technology that comes in, people go around this roller coaster journey across the curve. And this was in our terms, our own journey across this curve. So just by getting this basic example running and seeing how responsive it was like we were triggered by this TFJS thing and started deep dive into the possibilities that it can unbox for us. So like I mentioned, we just started with points, but then next up, we just connected those points through something called a triangulation array, which was provided by TensorFlow.js themselves. So what this triangulation array provides us is how the different points that it is providing form a triangle. Now you might wonder why triangles. Basically, triangle is the most simple two-dimensional shape. So any 2 points basically form a line, but if you have to go in the second dimension, you have to make it a third point and join it as a triangle. And now the fun thing is because it's very simple, you can connect it to form whatever shape you want. It's just like a pixel where you connect dots and to make like a photograph. And the same way, instead of having square pixels, it's just like thinking of like triangles. And another fun thing is these same triangles can be used and folded across their edges to make any 3D shape as well. So it's like a really nifty way to make any complex shape without adding much complexity in the base geometry itself. Now, once we have the triangulation, I can take the position buffer data, which I'm providing WebGL earlier for the dots, but telling it how to connect those dots together. And then sending instead, now you can see on the bottom over here, it is the triangles instead of the points. So once we have the triangles, it formed like a polygon, and we can use those triangles and color them randomly. Now here, what I'm doing is using something called a fragment shader, which is one of the ways in which a GPU or a WebGL kind of prints out the image with different colors. So I can send for each vertex a different color, and it will color it in the triangle in that particular one. So I was inspired by this album art for Google Play Music Material Design UI, and I wanted to try it out and see if we can get a similar form. Now, it does have some similarities, but we can obviously see that on the left, the mesh is very low polygon, so the triangles are not as fine, whereas what the TensorFlow mesh provides us is very fine grained for certain parts of the face, and that's specifically because they wanted it to be very much in line with fake face filters, so that they could use something like a social media, Instagram or Snapchat like filter, but directly in the browser. Now, the one hurdle you might face when we go forward is you might want to superimpose a specific image. And there was a problem in this where if you have to use that over a 3D object, you have to use UV mapping. And that's basically how it tells what part of the image corresponds to what triangle in the 3D mesh. And for that, we need to have specific locations within the image mapping to each particular triangle. Now, unfortunately, the GitHub repository for TensorFlow Face Mesh didn't have these coordinates, so we had to go ourselves manually dig through and pinpoint those in like Inkscape, go one of the 468 points at a time, and then mark those locations. One cool trick we figured, of course, is that faces are symmetrical, or like the face coordinates face mesh is providing are symmetrical. So we can just do one left edge and then use that as a center line to mirror the points out to the right side. And as you can see on the right, we have got the initial face mesh coordinates as provided in the sample texture, mapped directly onto the 3D face. Now, once we figured the UV mapping, it was all about getting the textures onto it. But another hurdle we faced on the way was that the textures or the projection used by face mesh was spherical one. What that means is, like, if we draw a circle on an image, as you see on the right, it comes up as an oval because it stretches and warps the face, the texture, as it projects it onto the 3D shape. Now, for that, what we had to do was come up with our own UV mapping. So basically, if you've worked in Blender or any other 3D rendering software, what it allows you to have is a projection from the view itself. What that means is, whereas on the left, you can see each nose point over here on the left is getting good enough real estate as a texture. On the right, it doesn't, because you can imagine camera being right in front of the nose point over here, and its shadow being projected in the back surface. Now, what this allows us instead is, if I draw a circle on this image, it will come directly as that onto the 3D map as well. So this allows for a lot of fun interactive exercises around building your own AR masks, and it's going to follow. So like I said, we could pick any of these amazing cultural masks done by artists and try them out as like AR filters. So the GIF over here, you can see how responsive it is and how it's working really well. There is a lot of this shine and lighting also happening. And what I'm doing is the same fragment shader I mentioned. Instead of passing in the color, now I'm passing in the texture and the texture coordinates for each of those. And now it directly maps those triangles from one of this image to the particular point within the face mesh as it's predicted. Now, this is like where we are at the peak of inflated expectations. So we've done that, we've been triggered by the whole expectations of what TensorFlow can provide us. So we've climbed up with all the different things we've done. And now we're feeling like, okay, we are totally onto something. We should keep persevering and figure out how to get animated working. Now, as we have gone through these multiple iterations over WebGL, we realized that it does involve a lot of code. And it might be better as we're moving towards a more production-friendly use case that we pick up a library, and that's where 3JS comes in. So as you can see, like 3JS has like boilerplate functions for all the basic things you would need in a 3D environment. So you can create a scene, add a camera, add lights, add geometry, which we have, and then the material which will have the texture and all those things. So all we have to provide is a texture file path, and then it directly does all the mapping for us. And then we can just run the render loop, and it just works on. Again, the code over here is very much simplified. We wrote our own abstract class with all these functions being called, but you get the point of what's happening as each and every step happens. And then you can see it's much better in some regard from the previous Kathak example to this Thayyam one, where the edges are a bit more soft, the shadows are soft, and then we get like that's all happening through the anti-aliasing and the alpha settings in Three.js, which would have required another added effort to get embedded into the GL. But there is like a hurdle we crossed into this as well. So Three.js might as well look really amazing in this form, but compared to something like Animoji, which is like highly expressive and has the power of all the IR depth sensor the hardware provides, it doesn't level up as much. So we did like a few trials around it and figuring out what would work best here. And Praveen here did like this amazing synchronized recording of his face with Animoji and the face mesh model. And you can see over here, even though the tracking is really awesome in face mesh, the face expressions do fall short. And our original experiment, our hypothesis around showing the nonverbal cues through face mesh didn't fall as per our expectations. So from that inflated expectation, we dove directly down to the trough of disillusionment. And we were like figuring what can be done now to use what we have invested so much time in and see where we can take it up. So bit of like introspection, retrospection, and all that, we came up with a few ideas, which I'll now hand over to Praveen to walk us through.
Thanks, Samarth. I'll just switch to my screen.
Okay.
Yeah. Yeah. Thank you. Okay, so after reaching the trough, we were left at what you guys already see, the faces, right? So we started thinking in what different manners we could use the similar technology. So one of the first ideas we came up with was using these cultural artistic forms, which you could see, like we used the painting by Jamini Roy to take that face and see like how it looks with the face mesh. We also tried face masks, the traditional face masks which we use in our dance forms. So the second one you could see like the chow dance mask of a demon, and then we also tried South Indian charial mask. So we went into this area thinking that okay, maybe the association with these cultural masks can be brought with this AR format of face mesh and integration. And after this, we thought that okay, let's try some more ideas. So this was the second idea which we were discussing since we started this project after the lockdown, and it has become a reality of life that we have to use the face mask. So we thought that how can we make these face masks on our face filter, where we could also express ourselves through just like an emoji. And here the challenge was to cut the face mask to the point where your nose is visible, below the nose is having the mask, and above that it's clear. So we figured that out by using images or textures which were having transparency or alpha channel above this part. And after this section, we thought that okay, and this was a 2D image we were trying out through the face mesh. So we thought that okay, what if we could try a actual 3D object, and we took a GLTF format of 3D object to place it on the face mesh. It had its own challenges because now since we made the face mesh with as you can see, like the face mesh, it doesn't have so much orientation expressivity, right? So the problem with these 3D objects were that they were coming out very weirdly when you move your head on the left or right. But we thought that okay, this can be a good way to you could make your own 3D masks and get it printed or get it produced by a third-party vendor, and you could like check it out before even you make an order. So this was another idea which we started playing with, and from here what happened was since we had the 3D object now, we thought that okay, let's figure out something with a video texture, because we already know the 2D texture, the static textures we could render easily even with cutting the face part. So we thought that okay, we just have to change the image files with the video files. So this is another result which we came up during the exploration, that we could play videos on the face, and maybe we thought we could use this as a sort of a playful AR app where you could run some effects on your face, and even later on we thought that okay, it could work really well if you do something with a projection mapping on the face and this type of program running on the system with a 2D camera. Uh, After this we thought that okay, this is a very heavy thing. Okay, just let me get back to the last section. Another thing I would like to tell you about the video texture part is that we realized a shortcoming here with the model and the video running simultaneously, is that the systems which could run this program had to have a good graphics card, or else the GPU rendering will drop the frame rate. So you could see, like in this GIF, you could see that they are playing, but you could see there are some gaps. So there was this one learning that if you are running video with the face mesh program, the frame rate drops. So it's better to work with a better machine when you are trying to do video texture on using TFJS. Okay, moving on. We were then figuring out, like okay, we have cultural mask, we have the normal mask, we had some 3D mesh mask which can be used in activism, but we wanted to make it more accessible for people. Where something like people could just make their own artwork, and then they could directly in real time see it on their face. So it's not you get a agency in your hand where you could see your creation live on an AR camera without using any third party platform like snapshot. Sorry, I am very bad. I don't use that thing, or something like Instagram filter. Okay, so this was the idea which we came up, which was very simple in implementation, where you could see the face mesh on the right side, and you just have a brush or your mouse cursor, and you choose a color and the size of the brush, and as you move or as you paint on the face, you could see real-time rendering on the camera feed, on a 2D camera feed. So this led to an idea that okay, this can be a very good way to engage artists, traditional artists actually, who are already making illustrations or doing some physical artworks. So using this concept, we started pitching. Okay, we started discussing with different artists, and we came up to this point where we realized that this could work, because we had few feedback from traditional artists, contemporary artists, and they wanted to experiment with this, and this was a good enough point in our exploration, that we figured that this technology can work with something like a face mask, where you can render the mask as you are painting in real time. So taking this concept, we went further with this idea, and Samarth contacted Chandigarh Museum with the concept that okay, can we use this face mesh concept, or a face painting concept especially, to use with to engage more contemporary artists and Chandigarh Museum artifacts. So with this, the idea came to us that since there was the World Environment Day was coming this year, which is taken by United Nations, and this year's theme was biodiversity. We thought that why not create a social media challenge along those lines, and we came up with this face paint challenge, which we where we invited artists, most of them traditional artists who were using paintings, canvas, watercolors in their artwork, and we wanted to get them like to try this technology out, where they could create a face paint output using simply just uploading their artworks on a portal. So for that we created these sort of templates which you could download through a website. So they used to go to the website and they get to download this template, and whatever they are drawing, they just draw it on these face mesh, right? And that's it. Like they just had to draw it, and there was this upload section where they could just upload it and even check it live, that how actually it looks when they put it on their face, and they try it out with simple camera. So they didn't even need any special platform, any special program to be running on their system. It could be done even in their simple iPads or tablets or even phones. So this was a very relief for many artists, that okay, this can be done, and it was a very enlightening engagement with them. We had a very good conversation with few of those artists along these lines, and at the end we got very interesting artworks, and you could check them on the showcase link provided at the bottom. These are the few of those which we had. So it was a mixed media thing, where some people did a actual face painting and then uploaded it on the websites. Few people did digital illustrations, and few people used even images and digital, like Photoshop formats to create the artwork for the World Environment Day. And bam. So that's how we reached the, like at a point where we realized that face mesh has a potential which can be used by artists and creators, even people who are exploring face mesh or AR, to use in their own creative meanings, right? So from this point, I think Samarth will be taking it. Samarth.
So yeah, basically, like if you can see through the whole exploration around using TensorFlow and WebGL together, is that what we discovered was that every technology in itself follows this hype curve, where you get like these emerging, like very high expectations of what it can possibly do, and then suddenly once you start building something, you realize, okay, maybe it's not at that level yet. So we started off with the expectation that we can possibly replicate an emoji directly into the browser using this. But then as we started building it, we realized, okay, this was intended for a very different use case. And we have to figure out what we can do best with what we have right now. I'm pretty sure, like as the technology advances, it will get to a point where we can do it. But currently, in its current form, it allows for amazing tracking. So the tracking is really good. There is the expressiveness of the mouse itself. So you can see that how the mouse perforation was visible. You can also make it sure that you can remove the eyelid part of it, like we did for the face mesh in the face paint. And then as you go about with this exploration, you figure out what are the capabilities and limitations of it. So this is basically for any developer who wants to get started in augmented reality and artificial intelligence, that you might feel that there is a lot that you can achieve, but it's only when you start trying it that you learn that, okay, it's not there yet for the prime time. So yeah, this was like a whirlwind tour of our own journey exploring this technology. Going forward, if you would like to learn what's next, or like how you can build it yourself, we are conducting a hands-on workshop tomorrow. This is with Node School SF, so it's in like US times. So maybe not as like as comfortable for everyone here, but the next day is Sunday, so maybe you might as well join it. So Saturday night tomorrow, 12:30 a.m. So technically Sunday, but yeah, you can register on the link above, and then where we'll go through step by step of how we went about building this. There is like we have simplified the code base a bit so that any beginner in JavaScript can also get started in it. Only like limited understanding of promises of those things would be good to have, because TensorFlow in itself works upon that. And but lastly, because we did all of these different explorations, we are open for collaboration. Like you can see, like there were a lot of half-baked ideas throughout this journey, and we're looking for ways where we can contact different corporations or institutes like museums to run such social media experiments or even the other ideas that they might have. So feel free to contact us. Our DMs are open on Instagram and Twitter. You can reach out to us over these, and I will just open the floor for Q&A. Okay, maybe we can just go through a few which we already see in the live comments. Currently, I'm seeing one question about is the GAN concept playing part here, and also how the TensorFlow.js API is working in the backend. So, unfortunately, no, there is no GAN involved because we are not creating images. This is just analysis of a video feed, and then once the video feed is there, we just give it to the API, which is working all on the client side. So there is not even a backend involved. So TensorFlow, what they did, the team at TensorFlow, what they did was they took existing native C++ API and then converted that into so that it could run directly in the browser in JavaScript. The model files are directly available. So what basically a higher level view of what TensorFlow.js is that it realized that all that computation, which all these neural nets are doing, are happening on the GPU. And there are ways within the browsers currently which they can directly use that GPU for that computation. So instead of going it at the native level, where you need something like CUDA or an NVIDIA graphic card direct plugin, you can use your browser and run that as a shared memory buffer to transfer all that computation onto the GPU and get the results back. Now, that does take some time in some hardware, but eventually, as you get up to the speed where things are working, you can get very responsive things as well. So the whole challenge in this is accuracy versus speed. So they might compromise a bit on accuracy, as we saw, but you get a really performant model which can run on low-end devices like a mobile phone as well, and that too in a browser. See another.
Pranjal,
Yeah,
yeah.
go for it.
No, you take it. I think you'll be
Uh,
much better equipped
nah,
for that.
okay.
Uh,
Did you
Reducing
use any
latency for the callbacks.
did you use any novel techniques to reduce latency for callbacks? Novel techniques to reduce for the callbacks. Not exactly. So my render loop was so the question primarily revolves around your predictions might lag and your render might want to run at the 60 frames per second. So there are ways where you just store what the prediction was in a stored array, and that array updates as and when TensorFlow returns an update. I've put that change in the workshop for tomorrow, but funny enough, it just worked fine for our production use case when we put it out for the museum. So if you go to the museum link, you can see in the code over there that it's just running it in the request animation frame, which is calling TensorFlow every 60 frames or like every 16 milliseconds, and it's able to respond. Okay, yeah. One trick we did use was we made sure like the camera is expecting only one face at a time, so it will only predict one face. So that way, TensorFlow already knows that it doesn't have to go for a second face as soon as it finds the first one. Using TensorFlow, is it possible to create custom mesh for body parts, like for wrist? Um,
I think for that you will use BodyFix. There is
yeah.
another library for TensorFlow which
Mm-hmm.
you can use. It segments the person's body in different parts. So I think that can answer your question, and that will be another area which will be really interesting to take, experiment with or explore, because we also started with these two options with face mesh or body fix, but we our concepts were more related to face, so we stuck to the
Yeah.
face mesh.
Yeah. Another thing for body pics was it wasn't as performant on phones, and that was one of the initial criteria we wanted to have because it was like a general masses thing, and we don't want to restrict to like laptops. But yeah, definitely it's possible with body pics.
Okay.
There was one more question from Engineering Guruji. How Spark AR works?
Okay. Praveen is the expert here.
Okay, I will just say if you have used Spark AR, it's like a mix of Unity and a node-based programming which you use, I think, in Rhino, Grasshopper, the node-based thing. And if you look at export file, when you finally export your Spark AR effects, it's a JSON file and one script file. So it's just a collection of JSON object which tells the AR filter on Instagram and Facebook that okay, which are all different elements are present and how they are connected to each other through what relations or what functions. Because most of the time we are using the nodes, so there's if you want to use a custom function, then you have to write a script. So for that they have an option of script. Other than that, it's everything is pre-built there, so it's just like it reads a JSON object, and on your phones or when you start a filter, the renderer, it takes up those information and starts playing the scene. So it creates a scene information in those JSON objects. I hope that answers.
Okay, I hope you all guys clear with the face painting with the TensorFlow. I would like to invite Mr. Ali for vote of thanks.
Hello, I hope you guys are able to hear me.
Yeah.
Yeah, Leah.
Yeah, thank you so much. So the idea, it was like 2 weeks, 3 weeks back. We were discussing it. Like I guess it has been a month now, right? And it was really an interesting idea, and I really liked it. And that's why we thought to bring it to the wider community of TFUG Mumbai. And I feel everyone, I was in the chat all the time, and it was really good. And everyone was excited asking questions, and it was really good concept. I really liked everything which you said, and it was so well explained. Thank you so much for both of you for giving your time and bringing this experience for all of us. Thank you so much. I thank you again on behalf of TFUG Mumbai and all our members who have attended this. We would definitely look forward to maybe host a workshop in the near future, uh, collect a feedback, and see if we could actually have you guys again, where we can do a hands-on kind of a scenario where they can develop something out of it. So do attend that workshop, everyone. If you're, you can just put the link in the comments maybe, and they will be able to see it. I guess it is tomorrow, right?
Yeah.
Yeah.
Yeah, that would be really awesome. You can definitely go and attend that, or we will definitely collaborate with them and host it maybe for us. Thank you so much once again from the whole team of TFUG Mumbai.
Perfect. Thank
Thank
you.
you.
Thanks for having us.
Yes. I just stopped.
Okay, so we'll end the stream. Thank you so much.
Thank you.
Thank
Bye.
you.